Okay, morning, ladies and gentlemen. Welcome to lecture 6. We're going to be doing composition, something you guys have actually done before. It's just the actual wording has changed slightly and we're applying it to classes. So it's something you have done, not something really new. You'll see what I mean in a few minutes. Just one or two announcements. Please make sure that you're trying to organize groups. I know some students aren't finding 4 members, so I've adjusted the Google form. So if you only can find like 2 members or 3 members, you can fill out the Google form and then we'll auto allocate someone to your team later on if you prefer that way as well. So I've adjusted the Google form to minimum 2 people, and then we'll allocate the other 2 people later on. We're still sorting out we're trying to get the final results from Informatics 1A, so we know which students are supposed to be in the class and who are not supposed to be in the class. That's the one and our main announcement I've got this morning for at least a group assignment. Can't do anything else right now, but let's start the lecture. So, as always, when we start a new lecture, we start off with a bit of did you know? Today we're looking at something more a little bit not off topic, but something different. The world's fastest supercomputer. Yeah, we looked at the specs last night. It's near insane. I would love to get a hold of it and actually play a game on this machine. It has 7.3 million cores and a speed of 415.5 petaflops. Okay, any clues on what the hell a petaflop is, ladies and gentlemen in chat? You can Google it. A petaflop. Game RC. Ladies and gentlemen, my PhD and master's was in games. It can run Doom. That it can. A petaflop, how to translate that into digits? Let me get the right numbering. Omar, a petaflop is a measure of computer processing speed. Yeah, a quadrillion. Thank you very much for the Larry Tesla approach there. Yes, it is a quadrillion calculations. It is extremely fast. I haven't specified the amount of hard drive space or the amount of RAM this machine has. You guys can go look that up. There's too much. There's far too much. Oddly enough, it's not running a normal CPU like our computers. It's running an AIM processor. An AIM processor is basically what runs your cell phone processor. Your CPU on your cell phone are generally ARM processors, and that's the ones they're using for the supercomputer. Any guess what operating system this lovely machine works on? Apple. Seriously? Unix, Linux, yes, there we go. Some good Windows Server. You got to be joking with me. That's a joke. Linux, ladies and gentlemen, Linux. I think a Windows Server would crash with that amount of space. It runs in a Linux-based system. One thing that picked up my attention when I was Ubuntu, a variation on Ubuntu, was an exascale error. I wasn't sure what an exascale error. What is Linux? Okay, that's something you need to Google for personal research. Linux is a free operating system. Anyone want to guess why Linux is called Linux? I'll give you a second to Google that and you'll figure it out. Linux is called Linux because, yeah, because of the name of that guy. The guy is so arrogant he named it after himself, ladies and gentlemen. The developer of Linux is Linus. He named it after himself. Okay, so Linux and Unix are free operating systems. Going back to exascale, that's something I haven't heard of before, so I did a bit of extra did you know, and I looked at exascaling. Exascaling is when they think a computer can actually match the processing power of a human brain. For an exascale to be reached, you have to get to an exaflop. That's 10 to the 18 floating point operations per second. So double the processing on this one. Actually, no, double it and add a bit more, and then you get an extra exascale system. So they still say human brain is faster. So if this is the size, and this is not one computer you're seeing here. These are the computer all connected together. The room is huge. Okay, if you do a Google on the system's name, I'm not going to butcher the name. If you do a Google search on it, you'll see the size of the room that this thing sits in. It's bigger than some of our houses. So for them to get an exaflop, which is double what that thing is, then they maybe can reach the processing power of a human brain in terms of neural networks and neural processing. So that's just some extra general knowledge for you guys. So we're still a bit away from getting to the point where computers are as fast as a human brain. Okay, so that's the general knowledge for today. I don't want to know the cost of building that. There's a joint venture by Riken and Fujitsu to build that. There is 500 supercomputers in the world. There's the top 500 supercomputers in the world. I'm guessing it goes in the billions. It's not something you set up for the sake of setting up, ladies and gentlemen. Okay, let's get back to Informatics 1B. We're going to look at composition, when to use composition, how to implement it, how to instantiate it, and how to represent it in UML. Composition is something you know. You just don't know that why you know it. So I'm going to explain composition, and then I'm going to show you why you know it. Okay, composition refers to a relationship between classes where has a relationship. So between classes, there are always relationships. There's connections. So in the case of composition, there is a has-a composition. Or sorry, has-a relationship. Now, if you look at the images below, and the classes are typically different. This is an important thing to keep in mind. Composition refers to classes that are connected but are not the same. Okay, so there's a connection between the classes, but they're not the same thing. Now, what does that mean? And we'll look now. A class, if we look on the side, we have a nice little mini type vehicle, okay? And then on the other side, we have an engine. Are these two the same thing? Okay, good. Everyone agrees they're not. But does a vehicle have an engine? That's composition. That's composition. A vehicle has engine. It has an engine. It has tires. That is composition. That's why the has-a relationship is used. Composition refers to classes that are connected to each other, a has-a approach. So we look at a car and another approach, cutting down the center, and you can see all the different parts. You can see that the car makeup is seats, seats, wheels, windows, engine, door, steering wheel, etc. There's lots of little parts that make up a vehicle. But let's look at this picture again. Can an engine exist without a vehicle? Yes, good. So you'll agree an engine. Can a vehicle exist without an engine? Really? So, okay, you can have a vehicle, but will it go without the engine? Bicycle, yeah, okay. It won't run. Okay, let's it won't go. Okay, so everyone agrees that you can have a car without an engine, but it won't work. That is composition. I've lost connection temporarily, it seems. Okay, there we go, I'm back. Okay, so a car is built out of all these different aspects. Okay, it has to be, a car needs all these different parts to exist, but the parts themselves don't need the car. Okay, so a car needs a seat. Okay, you have to sit on something, but a seat doesn't really need a car. That's what I'm trying to get to. So composition is about one object that is made up of other objects, but it needs those objects. This is composition. There's another term you might, if you Google, you might hear a term called aggregation. We're not going to do aggregation. Aggregation is sometimes composition almost. I'm not going to explain the whole detail of aggregation, but the main focus of today is composition, where an object is made up of other objects, and it needs those objects to exist. In the case of a car, it's quite easy to see if you look at the picture. We have the engine, the tires, the seats, etc. Okay, a car, okay, it depends where it is, can exist without tires if you're in Hillbrow, because within a few seconds your tires will disappear. Okay, no offense to anyone that lives in the area. It's just a very interesting area. What? I used to drive through Hillbrow every day to work. You drive quickly. Safe, thank you. Like integrated circuits, yes. What is the difference between composition and objects? There's no difference. Composition forms parts of objects. So composition is the relationship between objects. You'll see now. Firstly, let's try, like I've said a few times, that you guys have done this, but you don't really know it, or you haven't heard the term before. So you've done it. You've done it the entire second half of Informatics 1A. Whenever you did a record structure inside a record structure, that is composition, ladies and gentlemen. So here we have an engine rec, brand, power, model, thrust. We have a vehicle, and inside the vehicle structure, we have an engine rec. That is composition. Okay, so you guys have been doing it already. It's not something brand new to you. It's just now you finally have the correct naming for it. So when you were doing last semester records inside records, you were doing composition. You just were never given the correct name for it. This is composition. But composition is the relationship between objects. And now I'm going to show you how to take it from here into objects. So the principle of record structures inside record structures, but objects this time around. Correct. That's exactly what it is. Okay. It's just there's one or two extra things you have to do, but the principle is the same. Okay. So it's not something brand new entirely. It's just a few things you got to do extra to make it work. And it's extremely useful because of things like this, because of cars. We can design an object, an engine. We can design an object window. We can design an object door and use it in other areas as well. So the objects and classes can be moved around per se into different areas. So it allows for a more reusable environment. So I'm going to continue with the example of a vehicle. I know it's a bit of a boring example, but it is a nice one because we can look at a car and break it down into the different parts quite easily. So going into proper composition and class objects, here we have our engine class, okay, our instance variables, and here we have our public class vehicle. Again, the main thing here, and this is important to keep in mind, is we have an instance variable as type engine. Okay. Now the big difference is we have to build the object. Yeah, you guys are going to be working with 2 classes up to 4 classes as we go forward. The classes aren't very long, but you work with multiple classes, multiple files as well. Okay, we'll get to that in a few minutes. So here is the most important thing, is that when we create the vehicle, we also need to create the engine. And this is only in certain cases where in case we have one engine. We don't have multiple engines. We're not really concerned about, okay, how many engines are there in instantiating each object of the engine. So in this case, a vehicle, we're going with a car, has an engine. So we can create the object of type engine. This is the important part. You can't just declare the variable as type engine. You got to instantiate the object type engine. So this line is exceptionally important. You have to create the engine as well. That's the main difference between your record structures inside record structures and objects, is the fact that we have to create or instantiate the object of type engine. Okay, so when you're having a single object account, you can use the constructor of the class to instantiate the object. Okay. What happens if you have an array? And that's the thing we also got to look at. What happens if we have an array? And for this example, I moved away from vehicles. I went to a shop with apples. But is everyone okay with what's going on this slide? With the fact that we have one file engine and its instance variables, constructors, etc. Here we have our vehicle. We have its attributes, and the main thing, its composition, is the engine. It would have other, oh, my spelling's gone. No, my spelling's even worse than it used to be, never mind. Moving on from that slide. The property method looks like that, just to give you guys an idea. Not really much different to other property methods that you made so far. There's no real reason to make it any different. The only difference is it's as type engine, and the value is type engine. Okay, that's the only difference in the property method. The rest is you treat it as another instance variable. It just has a bit more features. Okay, now what about arrays? Now, this we got to look at. For this example, I went for a shop and apples. So a apple has a grade, a type, and a color, and other potential methods. I didn't go into all the details, but we need to now consider the fact that we have an array of said items. How do we work with it? We got to redim it, yes. We have to instantiate it, yes. But how do we do it? What approaches can we take to do it? Okay, it's not just simply a matter of redimming. So remember, redim simply reserves the needed space for the array. It doesn't instantiate. So this redim doesn't go and create all the apples. It just creates space for the apples to be stored. So we also have to instantiate it. Now, I'm going to present you with two ways of doing it, which is important. It's not just about going and instantiating everything, because you're going to chew up memory. The first approach is what being suggested. You just run through a for loop and instantiate everything. Not always the best idea. Sometimes it will work, but sometimes it's an excessive amount of memory being chewed up. So there are other approaches, which I'll show you now. So this is one approach. Remember, ladies and gentlemen, the way I teach and the way it should be done is we're teaching you tools, approaches, principles of programming. How you apply them isn't up to you, but you got to apply the right principles and the right approach to solving problems. And it's just not a matter of throwing things together and hoping it works. So that's just one approach where we can redim and instantiate all the different apples in one go. So if we have 1,000 apples, we have 1,000 apples in memory automatically. Chew up all your memory. The other approach is this way. Okay, I'll show you the other thing. I think I'm running out of slides actually, because there's not many slides to this lecture. The other approach is we instantiate the apples as we get them. So we redim them. Yeah, we can redim them. We can set the size of the apples. So it uses up a bit of memory, but it doesn't use up as much or as much space per se. There are ways to improve it, but we'll get to that later. So here we instantiate the shop, we get the number of apples. Then instead of using the constructor, I actually have a set number of apples subroutine, which goes and resizes. But instead of instantiating it there, I first create a temporary apple. I create a temporary object. I get all the information for the object, and then I pass the object into the array. So this approach only says once I've got the apple, now I'm going to go and instantiate them. Because remember, if we do it this way, they're all blank apples. There's no information of these apples. They're all just empty objects. But if we take this approach, we can have the grade, the what are the details, type and color of the apples already there, and we pass all of that information across to the array in the form of passing the object across, because we pass it by ref. So when we do this, we're passing it as by ref and we object across into the array, and then there's a link to the array stored here. So this is the second way of working with an array of objects, especially with composition. Hopefully I haven't confused you guys too much with this one. And everyone's gone quiet. I'm confused. This is in the form, yes. This is in the form. Okay, let me just read through the questions. Does that mean all apples will have the same color, size, and type? No. If we do it, or if we technically do it this way, they all have nothing because we haven't set anything. If we do it this way, that each apple will have its own grade, color, and type individually. Set a number of apples is a subroutine. So in the second approach, you have to count how many objects you have made so that you don't display a null in the array. Not really. You set the array and then you just work through the array. So in this subroutine here, I'm setting the size of the array to number of apples, and then I'm working through the array. Look, there is other ways to do this. I don't want to show you. Technically, there's a slightly better way of doing it where you only enter one apple at a time, using counters and other approaches. That also can be done. If we have time, I'll try to show it to you, but I'm going to first get you guys to understand the principles of what we're doing and then work from there. That's the problem, is which way is better isn't always there isn't always which way. It's more about which approach is the most applicable to you. As developers, you got to decide which approach to use. It's not always saying take this approach, it's the best. There isn't such a thing. You've got to keep an open mind and figure out the approach that solves the problem the best. So it's more about what is the problem and how you're trying to solve it. Do any of you cook? It's also an odd question now. Okay. Sometimes eggs. Okay. Let's take eggs. Would you throw eggs into the microwave to cook? In the egg itself, just as the egg, put in the microwave. How would you cook an egg with the shell? Okay. You could throw it in the microwave and have a huge mess, or you could do the proper approach and boil it. I'll explain that again now, but what I'm trying to get to is you apply the right tool for the job. Okay? So depending on what you're trying to accomplish, you use the right tool. So the example I gave of the egg and the microwave is a bad example. You don't combine the two unless you want to mess. Okay, if you haven't done it before, I wouldn't suggest it unless you want your parents to clean up a huge mess and fight with you. Unless you're living by yourself and you want to clean up a huge mess, yeah, that's also a situation. But essentially, when cooking or doing anything, you apply the right tool for the job. If you're trying to hang a painting on the wall, now we've got a different one thrown at us. I'll get back to that. If you're trying to hang a painting on a wall, you don't take a sledgehammer to hit the nail into the wall. You can make scrambled eggs in the microwave, yes, but that means cracking the egg. And then that's a different process. And I never said you couldn't crack the egg. Okay, it all depends on what you're trying to accomplish, ladies and gentlemen. Hand up, yes. Someone put their hand up, you can talk. Okay, yes, never mind. Okay, with programming, okay, another hand up. Give you a second. And nothing. Wait, there we go. No. Okay, with programming, with solving problems, it's all about using the right tools for the job. That's fine, don't stress. It's all about using the right tools for the job. It's not about which line of code is the best. It's about which principle and which approach you take is the best to solve the given problem. It's not about always just saying, no, I know better because this is what I've done for the last 10 years. It's about taking the best approach that's available now. Remember, you have to, IT isn't something that you learn once and never learn again. IT is something that you continually learn. So you need to apply different approaches to solving solutions. So you need to keep that in mind when you're looking at a problem. Which approach would solve it the best? Not what you've done in the past, but what you know now, what principles you've learned now, because IT doesn't stop changing because you've learned it already. Okay, that's one thing you got to keep in mind. IT is something. One of my lecturers always recommended keeping up with one area of IT to make sure you don't get left behind. Now, getting left behind in IT is very quick because IT adjusts very quickly. Every year, new ways of programming comes out, new principles of programming come out. So it's important to keep up to date with them. Okay, that's off topic, but it's important to not just stick with what you know because yes, that's what I was taught. No, you got to keep up to date with what's the current trends in IT. Okay, so let's go back through these different things so you guys can get a better idea what's going on. It's not something that's going to come in instantly, but you'll slowly grasp the idea. I think the array is the struggling point. Is everyone okay with creating a single object in the other object? Because remember, when we build the car, we build the engine automatically and we put it together. Okay, so basically, when the vehicle rolls off the manufacturing floor, the engine is made, it's there, done, solid. Okay, it can drive. And we have our property method to access it. Now, when we have our Apple and our shop, a shop will keep a supply of apples. Okay, but they're not going to all be in the front of the shop at all the time. They'll keep them in the fridge to keep them cool as well. So they'll be in different places. So that's off topic. Let's get back to the more important thing. You may know the number of apples when you start the program, when you create the store, yes, but you may not. That's the thing. You could keep that in mind. Do you know the amount of apples when you open the shop or not? That'll also affect your programming. In this case, I know the number of apples, so I can reuse a constructor that accepts the size of apples and resize it. I can then also, now I know how many apples, decide, okay, I'm going to automatically go and create all the apples. Okay, so if there's 100 apples, I'll create 100 objects, done. Objects are in memory, even though I'm not using them. even though I have no information for them. I've created the 100 apples. They all are blank apples. No information about their grade, the color, the brand, etc. No details of each apple. They're just empty in terms of detail. All the instance variables aren't set to any specific value. Or you have another approach where you instantiate each apple at a time. Okay, so you create the shop, you have your shop standing, it's there. Then you say, how many apples does the shop have? Has 20 apples. Fantastic. This is done in the form. This is all done in the form. You then set the size of apples. I chose to do it outside the constructor because I did not know the number of apples when I created the object shop. Okay, when I created the shop, I didn't know the number of apples. So I set the number of apples after the constructor. You can do that using a subroutine. Okay, I'll show you how to do that in a few minutes if we have the code, or I'll do it this afternoon in a tutorial. Then what I do is I say, for each apple, for 1 to number of apples, create a local variable, temp apple. Instantiate that apple. Get the grade, get the brand, get all the details for the apple. Then once I've got all the details for the apple, I send it into the array of apples for the shop. That's what's happening here. I'm passing the object temp apple across into the apple array for number 1. Then I do number 2, I get the details, I pass it across to number 2. Then I do number 3, get the details, pass it across with number 3. Then 4, then 5. So as I slowly create each apple, I pass it into the array for the shop. So it's basically me sitting at the shop receiving a box of apples and saying, okay, yes, this apple's fine, part of the shop. This apple's fine, part of the shop. This apple's fine, part of the shop. This apple's rotten, throw it away. Next apple. So I can create each apple at a time and add it to the shop based on its specific information. So wouldn't this be less efficient? Or technically, you have to do it in both situations. If you do it here, you have a bunch of empty apples with no details. So you'd have to go and put the details in for each apple. It doesn't really save on memory as much as you think. It's just more of how you're processing the information. Remember, you've got to consider on how you are processing the information. And ladies and gentlemen, we're giving you a basic approach right now. There is a way to wait, let me ask a simple question. Well, I don't know why I'm fighting this thing. Were you taught read and preserve last semester? I'm getting no, okay. Then you know you can grow and shrink an array. Okay. Some of you do, some of you, okay, some of you guys know about it, some of you don't. Forgot. What does readem do? What is the purpose of readem? Resize, correct. Okay, it resizes the array. Now, preserve is a second keyword. Anyone want to guess what preserve does? There we go. Resizes and keeps the content. So ladies and gentlemen, technically I could resize the array to 1, add an apple, then resize the array to 2, add an apple, resize the array to 3, add an apple, resize the array to 4 and add an apple. So I don't necessarily need to set the size of the array to 20 and then add all 20 apples. In this situation, with this code, I would have to. With this approach, I could do a different variation on it. Okay, so you can start to combine those ideas. Right now, we're looking at simple solutions. We're not too worried about memory space. We're not too worried about saving memory right now. We're trying to get you guys to understand the principal ideas of, okay, I've got composition, so a shop is made up of apples. So I must create the object of each apple and add it to the shop. Because can a shop work without, okay, say the whole job of the shop is to sell apples. Can it function without apples? Okay. So in order for the shop to function, they need apples. So you must create the object for apples. This is what I'm trying to get to, is you have to not just simply resize the array of apples in the composition, but you need to resize and create the objects. And that's the most important part of this. You need to create the objects of each apple in this case. Else there's not composition involved. Composition is the thing, how it links together. Now we still have some time. I just want to look at one last slide and then we'll start looking at code. So I went back to the example of a vehicle because it's a bit easier sometimes to do diagrams for vehicles. When drawing UML for composition, there's a specific way it needs to be done. So we have an engine. An engine can exist by itself. A vehicle is composed of an engine, and this is the symbol for composition, a diamond. So you have a line going from engine to vehicle with a diamond connecting to vehicle, because vehicle is composed of engine. A vehicle cannot exist without an engine. A vehicle has an engine. An engine doesn't have a vehicle. So the location of the diamond is exceptionally important when doing composition diagrams. Which part has composition? An engine doesn't have a vehicle. A vehicle has an engine, so the diamond is here. Everyone okay with that? Okay. Omar, this afternoon we have to actually cover how to determine constantly increasing and decreasing. Unfortunately, it's something you didn't finish in Informatics 1A, so we've been tasked to do it in Informatics 1B. So we're going to cover the concept of how to determine if something constantly is increasing or constantly decreasing. It's not a hard concept, but we have to cover it nonetheless. That's the only thing I think we're going to cover this afternoon, and then we'll do a Q&A and discuss composition more. Okay, so we'll try to keep the lecture on increasing, decreasing calculations to the first half an hour or so, and then we'll move to a Q&A and discuss more about composition as well. Ladies and gentlemen, we've got to keep track of our time as well. Is it trends? Not or kind of trends. If you've got a constant increasing, constant decreasing. The thing is, we also have to keep track of the weeks and time, ladies and gentlemen. Like I said at the beginning of the lecture, we're in week 4. We have 9 weeks left. In the next 9 weeks, we still have to teach you inheritance, polymorphism, files, and a few other things. So there's a lot of other concepts we have to cover. So we can't spend too much time on composition and other things. A thing like focus on one thing alone. There's quite a few concepts and principles we have to teach you. Inheritance, polymorphism, it takes a bit longer than composition, because composition you are somewhat more comfortable with in general, I found over the years, because you've been doing it since last semester in terms of records inside records. Okay, so the concept of it is easier to grasp. There's always a recording. I know Eskom is cutting the lights in all areas. I know some of our colleagues also don't have power this morning. The recording will be on Blackboard and on YouTube for you to watch. Don't worry. Everything is on. Also, just a reminder, I'm going to start deleting lecture 00 and 01 videos off Eve, as it's almost been a month now. So next week I'll delete lecture 00 and lecture 01 off Eve. If you want to download them before then. But those will start to be removed. I only keep videos on Eve for a month, but they will remain on YouTube and Blackboard for the entire semester. Okay, so anything that is lectures are always recorded on Blackboard and uploaded to Eve and uploaded to YouTube. So there's 3 possibilities for lectures. Tutorials are recorded on Blackboard and uploaded to YouTube. So you have 2 ways to access those as well. Okay, but composition, the only thing you guys have got to get used to with composition is the fact that you've got to create the object. Okay, and that's the main thing you got to kind of get used to, is this idea of creating the object. It's not just about having the variable as type engine, but it's about creating that object. That's the main thing about composition that you got to get used to from last semester. And also this object has functionality. So I can say object engine dot start, object engine dot rotate in terms of the pistons. So it has functionality that goes with it as well, like any other object. Okay. Still have some time. I have about 10 minutes left. Any specific questions? I want to try and see if I can show you some code. Okay, I'm assuming everyone's somewhat comfortable with what we discussed. Again, ladies and gentlemen, if you're getting confused by what we're talking about, please post it in Discord or on YouTube, the comments. And then we know where you're struggling and we can post extra videos if need be to cover that concept again. As we can't just sit on composition for the entire semester. Mm. Practice. Informatics 1B is challenging. It always will be. It's just about practice. The more you practice, the better it becomes. Ladies and gentlemen, generally with programming, once you've understood the principles of programming, and I mean the principles, not just the language, it takes you about 6 months to learn a new language and about 3 years to 5 years to master a language. If you've been taught wrong, then you're not going to actually learn jack. Okay, so it's important to understand the principles of programming, not just, oh no, I know fancy terms. Okay. I kind of combined a whole bunch of classes when I was doing the code for the lecture side. So here's a vehicle object. Now, ladies and gentlemen, you'll notice one thing on the side here. I know it's not the easiest to see. Problem is magnifying sometimes makes it worse. I don't know. You'll see that I don't have one file. I have Apple, engine, shop, vehicle. I've got all of these different files for each class. Each class has its own VB file. Please keep that in mind. Each class has its own VB file. It's not about one file, everything goes in there. It's not about one button, everything goes in there as well. We do not encourage that, and we actually penalize that. You need to do modular coding and break up things correctly. So you break up things according to their functionality and according to their processing. So if we look at our engine, again, I didn't put much in it. I didn't do even the option statements when I was doing the code for the class. But the form here, okay, Shops is complaining. Shops is complaining because there's not only one constructor. That's better. So again, here, this is what we did for the last slide, is where we have instantiate the shop, read in the apples, and set the number of apples. So inside apples, doesn't have much to it. Inside the shop, we have a subroutine, set number of apples, which accepts a single parameter being this number of apples and resizes the array. We have a public property apples, which is exactly what you guys have been doing with arrays of strings, integers, doubles, except it's an array, it's of type apple. Keep that in mind when you're doing a property methods for a composition. You'll have one that is of type apple. So the property method is here, as you would expect. Again, some of the code is missing because I was just writing snippets of code so I could show you how it would work together. So here what's going on again is here you'd also do grade, you'd do the brand the type here and then pass it up. So this line here, this is important because what's happening is I'm saying shop Apple A is equal, so whatever element is, whatever index I'm at is equal to temp Apple. Okay. So this allows me to create the object and then save it or store it inside the array. You guys okay with that? Any questions here? I can upload it, but it's not the best code. I'll have to work on it. Because if you look at the code, it's actually got the record structures, everything's kind of smashed together. This type of code I do for your lecture slides is generally smashed together to get the snippets I need for your lecture slides. It's not really perfectly designed because I have record structures randomly added there because I needed a section for record structures. So it's not the best to upload. The slides contain everything the same. This is an exact shot of the slides. What is important, like I mentioned, is you have your different different files for each form. Okay, a shop wouldn't just consist of apples, bear that in mind. A shop would have other things, but the focus on today, the focus of this one was to illustrate how we work with an array of objects. Okay, because it does get a bit confusing because unlike previously, it's not just simply working with a variable or an array. We're working with an array of objects. That means we have to create the objects. Would the other products get their own class? Yes. But we're going to show you a better way when we get to inheritance as well. Okay. Inheritance solves this type of thing, this type of approach we wouldn't do like this with inheritance. But right now, I want you guys to focus on composition. We will have better approaches as you move on. Okay. And that's the whole point of this course. We're going to be showing you pieces of programming. Each one builds on top of the other. Each one is combined with the others. But it's up to you how to put it together later on. So we will show you a better approach on how to do this because this, I wouldn't actually do it like this. I would make use of inheritance and polymorphism, to be honest. But that only makes sense once I've covered it with you. So just keep that in mind. Right now, we are just focusing on understanding the principle of composition. So for now, yes, each product would get its own class in this context, and each product would have its own array. So for now, this is how you do it. Later on, you'll see that there's a better approach. It's just we can't throw everything at you at one go because it would overload anyone that's programming. It's not possible to do everything in one go because it would just be an overload and you would understand or not grasp the concept of what we're trying to do, which is more important. Okay. Yeah. Okay. Any other questions, ladies and gentlemen? We've got about 3-4 minutes left and the lecture's finished. Again, we will cover a bit more of this afternoon if we have a chance. I'll write out a bit of this in the tutorial as well. But it just get the concept. We will go over this on Monday again. I'll have another set of slides on composition on Monday, and then hopefully on Wednesday we can start with inheritance. Because, like I said, composition isn't something that's brand new to you. It's just a new concept. 1B is difficult. 1B is also faster. Okay. Remember, ladies and gentlemen, we've gone from the assumption of that you don't know how to program to you can program, but we got to teach you how to program better or program properly. So we're now teaching you some more principles of programming. So it is going to be a bit more difficult. It's applying more principled programming, a lot more structured programming. It's not just about solving a problem and yes, it works. It's about solving a problem in an effective and correct manner that's usable within a bigger system. Okay, and again, the team project is only going to be done in Practical 9 or Practical 10. It's not, the team project only exists in Practical 9 and 10. All projects until then are solo. please, I don't know how you guys, some of you guys are thinking that team project is only much later. We'll announce it. We'll give you details on it. As some people are still trying to find team members. Again, I've updated the Google form. If you can't find 4 members, it'll accept 2 members, and then we'll auto allocate you the other 2 members when we start auto allocating. Hopefully next week we'll do the auto allocation. But again, ladies and gentlemen, we have semester test 1 coming up on the 3rd of September. So we also have that to deal with. So yeah, we have lots of work to get done. Informatics 1B is not difficult. It's just a lot of new concepts. That's the problem. But we will get there. Don't worry. That's why we have the tutorials. That's why we have the Saturday tutorial. That's why we have practicals. They're all there to help you build on the information you know. That's enough from my side for now in terms of ranting, I guess. Any other questions? I don't know. I don't want to comment on if we go down to lockdown on level 2. That's something I can't actually give a comment on. That's the university itself. The lockdown levels and university, that's something else together. I'm not going to speculate. What time is this? Does the Saturday tutorial start? 10:30. So they also are recorded, uploaded to YouTube, and on Blackboard. Normally, the Saturday tutorial is a walkthrough of the solution of the previous week's practical. So Mr. Singh will sit through and go through practical. In this case, he'll probably be doing practical 3 with you guys in the Saturday TUT step by step. So if you've got stuck with the practical, he then helps you with it. So we can't even consult to the tutor in contact now. You can speak to the there are tutors available on Eve most of the day, or on Discord most of the day, so you can speak to them as well. Just make sure their times are correct. Just check the Eve roster, and if you go into Discord, you'll find an assistant if there's the correct time. So you guys still have contact with the tutors. That's not gone. That still is there. The tutors are just available on Discord. Legend, unfortunately, this is how it's going to be for a while, I think, until maybe next year. I cannot guarantee or say anything along those lines. We all don't know, but we're just doing the absolute best we can do with the current situation. So there is contact through Discord with myself, Mr. Van Edem, and Mr. Van Westhuizen. There's contact to your assistants through on a Friday afternoon through Discord. There's contact with the tutors through Discord. You can email us as well. So that's the only way we can contact. You can send code over Discord through DMing myself or Mr. Van Westhuizen and ask questions. You can't put code in the chat for any of the assistant lab stuff. That just causes issues. So you normally DM the assistant with the code. Any other questions, you can just post in Discord and we'll get answered eventually. Okay. But that's it. The time for recording is up, so I'm going to stop recording.